Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the metallic and the non-metallic reactor. So let us study the metallic reactor first. The metallic reactor. What do we understand by metallic reactor? The tendency of an element to lose electron and form cations is called the metallic reactor. What do we understand by cations? Any element having a positive charge, that stands for cation. I have taken example capital A, and it's having a positive charge, so it will be a cation. Now, metallic character of an element depends upon the following factors. The first one is the atomic size. Larger the atomic size of an element, more readily it will lose electron and hence greater will be the metallic character. So larger the atomic size, the more readily the element will lose electron, the more readily it will form a positive charge cation. That's why it will have a higher or greater metallic character. The second factor will be the effective nuclear charge. Now, lesser the effective nuclear charge, more will be the loosely bound outer electrons, more easily they will be lost, and hence greater will be the metallic character. It will form cation very readily, hence lesser the effective nuclear charge, the more will be the metallic character. Let's come to the third point, the ionization energy. What is ionization energy? It is the energy required to lose the most loosely bound outer electron from an element. So if lesser the ionization, if lesser the energy is required, that means more readily the element will lose electron, and hence the greater will be the metallic character, because it will form the cation very readily. So that's all about the metallic character. Now let's study about the non-metallic character. What do we mean by non-metallic character? Now it's non-metallic character. Now the tendency of an element to gain electron and form anion is called the non-metallic character. Now let's talk about the anion. Any element which acquires a negative charge, that stands for anion, and the tendency of an element to gain electron to form anion is called non-metallic character. Now, the non-metallic character of an element depends upon the following factors. Again, the very first one is atomic size. Now, smaller the atomic size of an element, the added electron will be more closer to the nucleus, thereby increasing the tendency of an element to gain electron, because the added electron will be more closer to the nucleus. That's why there will be the increased tendency of an element to gain electron. So hence higher is the non-metallic character, because it has gained electron very readily, because added electron will be more closer to the nucleus, and hence more is the non-metallic character. Now let's talk about the second factor, the effective nuclear charge. More is the effective nuclear charge, more will be the forces of attraction between the nucleus and the added electron, thereby increasing the tendency to gain electron, and hence higher is the non-metallic character. Now let's talk about the third point, the electron gain enthalpy. Now electron gain enthalpy, what is electron gain enthalpy? It is the energy evolved or liberated when one electron is added to the isolated gaseous atom. So more the energy liberated, more the tendency of an element to gain electron, and hence more will be the non-metallic character. So here I have written, more is the highly negative electron gain enthalpy, more is the tendency of an element to gain electron, so more is the non-metallic character, that is more is the tendency to form the negative ion. That's why it's a higher non-metallic character, due to the higher electron gain enthalpy. Now let's discuss general trends of the metallic character, non-metallic character in groups and the periods. Now it's a trend of metallic and the non-metallic character in groups and the period. Here I have taken the example of, first of all, group number 1. Let's talk about the trend of metallic and non-metallic character across the, or down the group, sorry. Now down the group, what will happen? Down the group, what will happen? the number of shells will increase, due to which what will happen, the atomic size will increase. The third is the effective nuclear charge will decrease. The effective nuclear charge will decrease. Thereby what will happen, the ionization energy decrease down the group, due to which what will happen, due to which our metallic character our metallic character increase down the group. All the above four factors will enhance the tendency of an element to lose electron. Thereby metallic character will increase down the group, and vice versa. And vice versa, what will happen, non-metallic character will decrease down the group. The non-metallic character decrease down the group. So it's a general trend of the metallic and non-metallic character down the group. Now let's talk about the period. Here I have taken the example of period number 2 is lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine, and then finally neon. Now from left to right, now I am writing from left to right, what gonna happen when we move from left to right. The very first point, the shell number will remain same. The shell number will remain same. Now the effective nuclear charge will increase. The effective nuclear charge will increase. Thereby what will happen, the atomic size will decrease. The atomic size will decrease. Thereby what will happen, the ionization energy will increase. So it will be very tough for the element to lose electron as ionization energy is increasing. The ionization energy from left to right will increase, but on the another hand, the electron gain enthalpy will increase. The electron gain enthalpy will increase, thereby which shows that tendency of an element to gain electron will increase, which signifies that from left to right non-metallic character will increase. From left to right, the non-metallic character will increase. Now down the group metallic character will increase, and across a period non-metallic character will increase. Now here we can also write that vice versa, what will happen from left to right, or we can say across a period metallic character will decrease. Metallic character will decrease. Now that's all about the trend of metallic and non-metallic character down the group and across a period, and I have shown that down the groups. Metallic character will increase down the group and non-metallic character will decrease down the group. But across a period, non-metallic character will increase across a period and vice versa, metallic character will decrease across a period. Now here I would like to specifically specify the one exceptional case, that's of group number 18. Group number 18, as we all know that group number 18 are the noble gases. Now let me write the group first. The group is helium, neon, argon, krypton, xenon, radon and the oganesson. All these noble gases has closed shell electronic configuration as ns2 and p6. I am writing it is completely filled electronic configurations. Due to the completely filled electronic configuration, they have no tendency to gain or lose electron. Now, due to which they have very high ionization energy, and on the another hand they have positive electron gain enthalpy. Electron gain enthalpy. For all the members of the periodic table, the electron gain enthalpy is a negative value, but for the case of noble gases, electron gain enthalpy is a positive value, which signifies that they have no tendency to gain or lose electron. They will not gain electron and they will not lose electron, due to which they does not show the group number 18. The group number the group number 18 does not shows metallic and non-metallic properties. Metallic and non-metallic properties, and the main reason is that they have completely filled electronic configuration. So now let's discuss this trend in the periodic table. So I have taken this periodic table. Today we have talked about the metallic and the non-metallic character, and I'm here mentioning that first of all down the group. Here I'm mentioning that down the group what will happen, metallic character will increase, and on the another hand non-metallic character will decrease. Now let's talk about the period. If we grow from left to right, if we are moving from left to right, what's gonna happen? Non-metallic character will increase. Non-metallic character will increase, and on the another hand metallic character will decrease. Metallic character will decrease. So these are the trends that we have read in the today's lecture. So this signifies that what? This signifies that like cesium, francium are the most metallic elements of the periodic table, and on the other hand, when we are discussing about the metallic and non-metallic character across the period, we are discussing that up to group number 17 only, because group number 18 is inert. The group number 18 is inert group elements, inert elements group, sorry. So we will not consider the group number 18 in the metallic and non-metallic properties. That means we are discussing about the metallic and non-metallic reactor across a period up to group number 17 only, and here we can say that fluorine and chlorine are the most non-metallic elements. So the bond formed between the cesium and the fluorine, or we can say cesium and francium and the fluorine and chlorine, will be the most ionic compound which we are going to discuss in the next lectures. So I hope you got the point that when we talk about the any trend across a period, we discuss that trend up to group number 17 only, because group number 18 is a very inert element groups due to the stable electronic configuration, due to the stable electronic configuration. So they are inert, they have no tendency to gain electron, they have no tendency to lose electron, they will not form cation and they will also not form anion. So group number 18 is a properly inert elements group, so we are not going to discuss their trend in any of the properties related to the reactivity, that's metallic reactor, non-metallic reactor. These properties are related to the reactivity of the elements. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.